So now that we have studied some of the more higher-level concepts behind class design and object-oriented programming, we will look at the code and syntax behind object-oriented programming. So there are a lot of things here that you've probably noticed that are new, but this is okay. We will address them all within the next few minutes. So the first part I'd like to draw your attention to, if you haven't noticed already, is that there isn't just one file anymore. There are three. There's this H file, which is a header file, which you are more than familiar with as your IO stream or your string or what have you, the different files that give you the ability to use different functions that are provided by the compiler. And there are two CPP files. One of them has the same name as the header file, and the other has main, which contains the more familiar int main. But I like to start in the H file. So next, I'd just like to briefly point out why these compiler directives are here. This is basically just to keep the compiler from including a header file more than once. That can cause a lot of issues when you go to compile. It is good practice to keep in your programs, but this is not technically a part of class programming. The important part here is the class definition, which is right here. It's a very simple syntax. You just say class, and then you give the class a name. In this case, it's human. This sets the data type of the class you're defining for later use, and then brackets, followed by a semicolon. Everything inside the curly brackets is your class definition. Now, the reason we split up the class into two files, if you notice there was the human CPP, is because in the header file, this is just supposed to define everything in the classes. You're supposed to just define all the functions and all the variables, but you're not actually writing any code. Here, you just literally just say, this class has these variables and these functions. So this is probably a good place to start. So since we have the human name, we'll just keep using the same metaphor that we've been using. We're going to just define some of the variables and functions of a human. So the first thing you need to consider when writing a class is the access restrictions of the variables and the functions. So if you remember from the last video, we had public, which was accessible to everything inside the class or outside. It doesn't have to even be in a class to access everything in public. There's private, which these variables and functions are only accessible to functions within the class, so stuff that is defined between these two brackets. Those are the only things that can access anything that's in private. And then there's protected, which again is everything inside the class can access, but if you have other friend classes, they can access it as well. So you might be asking, okay, how do I use these? Well, firstly, if you don't tell the computer anything, it's assumed to be private. So everything right here is technically private. If you declare anything without anything saying public, private, or protected, it's private. However, it is better in this case to actually explicitly declare private by using a label. And that just looks like this. It's just the word private followed by a colon. In this case, everything that follows this label will be private until it reaches the next label. So this is usually better practice because in this case it's clearer that you want the variables and functions that you have to be private here, that you want them to be private. Because you could put them out here and either have forgotten that it was private, or maybe you did want it to be private, but the intention is not as clear as it is following a private label. So I would recommend just to use the private label. So we'll begin in private. Now, this will diverge a little from our discussion on protected and private from before, because there are some things that don't carry over. So we'll take height, for example. We're going to put that in private. Now, you could go and push someone up against a wall and measure them. When it comes to CS, when you put a variable in the public space in a class, this requires more memory because it needs to be open to the entire program, not just a small bit of it, and so that can cause some issues. So it's usually good practice to actually declare most, if not all, of your variables in private. So we will have their height, have their weight as well, their age. Actually, make that a double too. That way you can have a more refined age. And their name. So you will notice that I'm using the standard namespace explicitly here, because technically a class is also a namespace. So you're not likely to run into issues, but it is better because this way, again, just kind of like the way it was with private, you're more explicit about where your data types are coming from. Another point to comment on here is that when you start using functions that have variables that might relate to height, so you might have another height variable or another weight variable that you get from some outside source, and you want to set it to the internal variables, you will want to be you will be very tempted to use just the same variable name. Except the problem is you're running into a naming conflict. So inside whatever function it is inside the class that you want to, like, say, set the height. And you have this other height variable, and you want to call it height, but you also have this height variable that is already called height. You can't call them both height because you'll confuse the computer. So the common practice to avoid this is to put to give it an m underscore prefix. This just basically says this is a member variable height. So you can say that everything that's declared in the class definition is a member variable. So any variable in the class definition is a member variable. So you can give it this m underscore prefix, and so that way you're more explicit about which variable came from where. And of course, you can also have functions in private. We'll make a think function so that the person can think. So now we'll move on to public. So one of the important pieces of a class are its constructor and destructor. Now, the constructor is a function that runs when the object is created. It sets the class up so that it is ready to perform whatever purpose it has. Not all classes can start just being raw, straight out, whatever the compiler's default values are for the variables. Those don't always put the class in its ready state. So if you need to perform extra initialization on the class, you would do it inside the constructor. And similarly, the destructor is called when the class is destroyed. When the class is no longer needed, the computer will free up space by deleting the object. So to declare a constructor, you just put the class name and then the parameter list. Now you'll notice I did not put a data type here, not even void. That is because class constructors don't have return types. This is something that is very explicitly said in the C++ definition. So you just have to remember this isn't void. It's not anything. It's just the name of your class, case sensitive. So here you'll notice that our constructor has a parameter, which means basically when you declare your object, you have to give it a parameter to complete its initialization. So in this way, it makes it possible for you to complete initialization of an object while the object is still somewhat aware of its environment, so it can initialize itself so it is ready for the particular environment. Or so that you can change some of the object settings straight off the bat when you declare it. So these are some of the reasons why you might have a parameter in your constructor. So following the constructor, we have the destructor. And this is very similar in syntax to the constructor, except it has a tilde before the class name. And it also cannot have any parameters. This is one of the special cases where the function must have nothing between these parentheses. So whenever you declare a destructor, it has to be able to perform its function using only the variables that it has available. Depending on how you've declared the class, it sometimes isn't even possible to call the destructor because the computer calls it automatically after certain conditions have been met. So if you haven't already noticed, at this point I am also prototyping functions. I'm not actually declaring any of the logic. This is because in the H file, like I said earlier, you just want to say what is in a class, not necessarily what the class does. That is what the CPP file is for. This makes it easier for your class to this makes it easier to read your class, because that way people can look at your class and say, oh, it has this function, this function, and this function, which do this, 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 and this. As long as you follow consistent naming standards and your names convey the function of each function, then it will be fair. It will be relatively easy to see what each function in your class does. Because if you have the actual logic coded into the class definition, it can be difficult to see each individual function. So now one of the things you might have thought at this point is so if all of the variables are in private, how do I get things that aren't within the class to be able to access these variables? Now, so like say I want to know this class's name, but it's a private variable. So this is done through the use of what are called getter methods. You literally, it is the return type of the variable, and it's usually just get and then whatever the name of the variable is, and then it has no parameters. This allows you to get around some of the memory concerns, because when you call this function, it is sharing it explicitly with one other piece of the program, not the entire program itself. And the function itself is a little later on the program to have in public. So this is usually what is done to get variables that are in private into the public domain. So we can add one for all the other ones. Actually, no. It needs to be get height, weight, age. So at this point, this is kind of what a class definition would look like. You would have everything in private. You'd have all your variables declared that the class needs, any functions, and then again any functions and variables inside public.